Welcome back everyone. So in this video I will be talking about the derivative of trigonometric functions, only the ones that relate to year 12 methods. Okay, so it's actually fairly straightforward. So the derivative of, oh that's not right, d dx of psi of x is cos of x. The derivative of cos of x is negative psi of x, and the derivative of tan of x is 1 over cos square of x, which it's also sometimes written as sec square. So sec x, or sec tan, I think, it's 1 over cos. So the one thing to note with derivative of trigonometric functions is the angles will not change. The angle, so will not change. We'll talk about this more when the angle gets more complicated, but I think that's the main thing. You also given these rules in your formula sheet for board exams, but the form that is given is it's actually AX. So you just need to multiply with the derivative of the angle, really. So, but notice how the angle still doesn't change. So if the original angle is AX, then the angle of the derivative will also be AX. Let's think about, well, I'll give you some examples now. So before we start, these will be assumed knowledge. So all of the examples I'm about to show you might also have derivative of power and polynomial functions, derivative of exponential or logarithmic functions, as well as chain rule. I think we're going to focus a lot on application of chain rules in this one. Okay, so 10 examples again. We need to find the derivative of the following. So this is the first one, y equal to psi x. So dy dx. I think a simple way to remember how to derive trigonometry is you derive the trig and then you multiply the answer with the derivative of the angle. So the derivative of psi of 2x is cos of 2x, and then I have to multiply that with the derivative of the angle. This is essentially using chain rule, but this question is so simple that it's probably not worth it to write the whole chain rule out. So I'm just going to write as 2 cos 2x. So that's the answer for example 1. So example 2, very similar to example 1, it's just you have two different expressions that you have to derive here. So you just need to make sure you do each of them separately and be careful of any plus or minus between them. So the derivative of psi of x is cos of x, and the derivative of cos 3x is negative 3 psi 3x. So once again, the angle doesn't change. I'm going to put this minus back in and then put this on a bracket. So I can write the answer as cos of x plus 3 psi, 3 psi 3x. Okay, so that's example 2. So let's move on to 10. I think the main issue people have with derivative of tan is that they don't remember what it is, but it follows the same principle as the derivative of psi and cos. So derivative of tan is 1 over cosine. So 1 over cosine squared. So you're going to have 1 over cos square of 5x. Once again, do not change the angle, and then multiply with the derivative of the angle, which is 5. I'm just going to tidy up this expression. So 5 over cos square of 5x. You don't necessarily have to write it as sec of square of 5x. If the question doesn't ask for it, I would just leave the answer like this. I do actually like cosine square of 5x more, because if this is a more complicated expression, it is easier for me to simplify if I can. All right, so moving on to example 4. So the only difference between 3 and 4 is, well, between 4 and the other 3 is this one, you have a polynomials in here. So you do the same things, just derive the expression. So this is negative psi of 3 minus 2x. Do not change the angle. I'm just going to put another bracket here just so that you can distinguish between the two, and then I'm going to multiply with the derivative of the bracket, or the derivative of the angle, which is negative 2 in this case. and then simplify. There's a minus, and then there's a minus, so the answer is 2 psi 3 minus 2x. Okay, so that is example 4. So moving on to example 5, it's very similar to example 4, it's just that the angle is a little bit more exciting, but you do the same thing, and if you find it too difficult, then you can find the derivative of the angle on the side beforehand. So if we just find the derivative of the angle, so ddx of the angle, this is just the bracket part, that is going to be the derivative of x squared minus e2x. Once you get very good, you don't actually have to write this step out. So the derivative of the angle is 2x minus 2e2x. So you need to derive x squared, which is 2x. The derivative of e to the power of 2x is 2e to the power of 2x. And then I can find dy dx. So this is essentially chain rule. So derive the trig first. So derivative of psi is cos. Keep the angle the same. And then you're going to multiply this with the derivative of the angle, which is 2x minus 2e2x. And that's the final answer. I don't think you can do anything else to this. There is no need to open the brackets. It doesn't simplify the expression at all. This extra bracket is just me being cautious to represent that this is multiplied with the cosine, not multiplied to the angle. Okay, let's move on to example 6. When you see something like this, sometimes students have no idea what this means. This is basically the cubic of cos. So whenever you cube a trig expression, we tend to write the power like in the middle. So if this is too confusing, you could write it as cos of x and then cube. So these two expressions are equivalent to each other. So when you have something like this, basically use chain rule. So I'm going to do that. I think I'm going to do the whole full chain rule here. So you can think of this as a composite function. So you have a cubic function, and inside there is a cos function. So I'm going to let u, so that's my intermediate, if you will, equal to cos of x. And then I'm going to use chain rule. So I can write y in terms of u. So y is just going to be u cubed because I have substitute cos of x for u in this case, which means that dy dx, this looks like n. Let's just, okay, dy du, sorry, it's going to be 3u squared. I've been using chain rules in all of these examples. This is just the first time that I have write it all out. And u is cos of x, just to rewrite that, which means that du dx is going to be negative psi x. So dy dx, once you get very good, you don't even have to write any of this out. I do recommend doing it if the expression is really complicated and you're in a high-stake assessment, so you don't make any silly error, because I've seen a lot of those when people derive. So dy dx, this is just straight up chain rule, is dy du times du dx. And so dy du is 3u squared, du dx is negative psi x. And the last thing that you have to do is, sometimes people forget, is you have to replace u for an expression of x, because your final answer should only have x in it. So I'm going to rewrite this because we know that u is cos squared. So I'm just going to write it as 3 cos square of x. And then let's put the negative at the front, and then there's a psi x here. So this is the derivative of this expression. Example 7. So look at that. So this is another composite function. So you can use chain rule to derive. So you just need to pick the correct u. And I think this one's fairly obvious that, psi of x is going to be u. So I'm going to let u equal to psi of x. You can use another letter, but this is just the letter that I always use, and it is a letter used in the chain rule given to you in the formula sheet. So u equal to psi of x, which means that du dx, I think the u dx is a lot better than u prime as a notation, just because you can tell that it is being derived in terms of x. But I guess in this case, it doesn't matter too much. So the u dx is cos of x. I can write y in terms of u. So y will be log to the base e of u, which means that dy du is 1 over u. So this is the derivative of the log to the base e. And now you can use chain rule. dy dx is dy du times du dx, which is 1 over u times cos of x. And last but not least, you need to replace u with an expression for x. So you would have 1 over psi x basically. So I could just write it as cos of x over psi of x. You could write this as 1 over tan of x. I don't think that is necessarily a simplification. It's just a different way to write the same thing. So I just stop here. I think that's fine. So that is example 7. Moving on to example 8. Oh, this is good. So this is like a composite in a composite. But let's just take it one step at a time. So I'm gonna let u be the power first. So let u equals to psi. It's not actually that bad. You just need to not forget to multiply a derivative. So this is u. Okay, the u dx, if you need to, you may do another chain rule here, but I think this one's okay. So what I'm going to do is I'm going to derive the trig. So the derivative of psi is cos. Keep the angle the same. So the derivative of this is this. Yeah, that is so easy to understand. The derivative of psi is cos. And then I'm going to multiply this with the derivative of the angle. So the derivative of the angle is x cubed minus 2x squared plus 1. So the derivative of the angle is going to be 3x squared minus 4x. Okay, so this is an expression of the u dx. Don't think we can simplify it anymore. Now I can also write y as e to the power of u, because u is this, which means that I'm going to need to write on this side because otherwise I might not have enough space. dy du is going to be e to the power of u, so nothing changes here. And then we can use chain rule, so we have dy dx equals to dy du times du dx. So I think what we're going to do is I may have to, oh no, I'll be fine. Okay, so e to the power of u, that's dy du, times, let's just put this first because so I don't have to do a bracket on the cos. 3x squared minus 4x cos x cubed minus 2x squared plus 1. Okay, so I'm basically just multiplying everything together. And last step is to, I don't know why I put a dot there and now I can't erase it. Okay, last step is to replace u with x. So you basically the answer is e of psi x cubed minus 2x squared plus 1. Because everything is so long, you want to make sure that your notation is correct. So if this is the power of e, make sure that when you set it out on your piece of paper that it looks really clear that it is not e multiplied with psi, it's e to the power of psi. So multiply with 3x squared minus 4x, and then multiply with cos x cubed. All right, what is going on? Let's try again. Cos x cubed minus 2x squared plus 1. I don't think I can do any simplification. This is the answer. It's fine. Just make sure you leave enough space for it. So last two examples, we've gone down to the denominator. Don't be terrified or intimidated just because you see this. You can just simply rewrite. First of all, this is the same as 2 to the psi 2x square. So you can move the denominator up to 2 and then psi 2x to the power of negative 2. So once again, this is a composite and you have a power function and inside you have a trig function. So I'm going to use chain rule again. So I'm going to let u equals to the bracket, which is psi 2x. So the derivative is just going to be 2 cos 2x. And then I can write y in terms of u. So y is going to be 2u to the power of negative 2. And this is a power function. You should be able to derive it. dy du is going to be negative 4 u to the power of -3. So multiply with the power. 2 times -2 is -4. And then subtract 1 from the power. So from -2 to -3. And then we're just going to use chain rule again. So dy dx is dy du times du dx. So dy du is that. So -4 u to the power of -3 times 2 cos 2x. And last but not least, I have to replace u with x. And I think I'm just going to put u down to the denominator just because I don't want to use a lot of brackets. And also I'm going to simplify the -4 and the 2 to -8. So -8 cos 2x. And then u is now becomes psi cube of 2x. Okay, so that's the derivative of 9. 10 is similar. Oh, this is going to be fun. Okay, so once again, I'm going to move the denominator up just so that I can see a power function. So we have 10 of 2x, oh sorry, x over 2 to the power of -3. So we're going to let u be just a bracket. So u is going to be 10 of x over 2. And then you have to derive du dx. So do the same thing. Take the derivative of the trig. So derivative of 10 is 1 over cos square. So 1 over cos square of x over 2. Do not change the angle. And then multiply with a half, which is the derivative of the bracket. I'm going to tidy this thing up a little bit. So I'm just going to write 1 over 2 cos square of x over 2. So I'm just multiplying the two fractions together here. And then y, you can write y in terms of u. Y is going to be 8 u to the power of -3. So dy du is, so multiply with the power of -24 u to the power of -4. Yeah, well, you can write the -24. You can move the u to the denominator. That's fine. And then we're going to use chain rule. We're dangerously out of space, so let's hope. I'm still going to write the chain rule step down. I normally always do that, but I may skip one step. Let's see which one. Okay, let's write this down. -24 over u to the power of 4 times 1 over 2 cos square of x over 2. Okay, so you need to substitute 10 of x over 2 back for u and then simplify. So let's just do that in one go. So we have -12. So basically just divide 24 and 2 here. And then at the denominator, I'm going to have 10 to the power 4 of x over 2 times cosine square of x over 2. And that is going to be my derivative. That is it for these examples.